Hello, everybody. Today we are going to look up some of the uh, hardware kind of designs that you are going to look into. Okay, so one is called field program gate array. Okay, this is one of the major developments of the latest things about of the 21st century, where they were used for kind of gate array kind of things to do some of the specific functions of repeated functions, and those kind of things were developed. Okay, and for memory management and things like that. Okay, so when you're looking into, last time we saw how the BST thing was constructed, and I didn't give the complete detail about the directory structures and other things. Okay, so there were just about four tables: IO table, memory table, then data table, memory table, then you have a process table, and what was the four things? Okay, one was process table, then IO table, input output table, then we have uh, memory table, and finally we had other kinds of tables. Okay, so there are about four to five tables, which this is called a table management group. Okay, those are called the table management group. So that is how the things were developed. So whole thing is some kind of table management. Okay, so don't think that it is a kind of like difficult. Process management is also a table management with respect to time, how we process certain things, those kind of things. How these things got developed is kind of like during the early telephony kind of things, and railway department and all those things, they found it difficult to maintain some of the timetables of people coming in, going out, and other kinds of things. And some of the things were based on calculations for paying the employee, the employee time coming in, going out, those kind of things. So it was quite difficult to do some kind of traffic management and other things. So because of the traffic management kind of things, signaling started coming in, and once we had signaling kind of things, then after that once the basic signaling, that is where it started about communication kind of environment. Okay, so that is how it started. And later because of the timetable that was written on the railway station and bunk station and other things, that how much time they came in, so it was just the table management. That is how those table management groups started developing, and that is how the basic process management group started. Okay, so it was process management, IO management, memory management, and other kinds of tables. Okay, uh, so those table management was developed independently for each one of those groups, and that is how the actual computer works. Okay, the processor as such is doing only a kind of whole list of table management. Okay, process itself is a kind of table management. Those kind of things are all developed. Okay, for a process, what you do, a process is dependent on what is called time. Okay, memory doesn't depend on time. Okay, process depends on time. Okay, signal depends on time. Okay, so these are the basic differentiation you have to know. Okay, memory table doesn't depend on time. Okay, so time is not much of use as far memory is concerned. Okay, so most of the things, when they want to store some things, they use what is called, to store all this information on the process management and other things. Okay, they use what is called memory. So memory is a critical part of any kind of architecture. Okay, so don't think that memory is not useful at all. Okay, any kind of process management, IO management, everything needs what is called a memory. Okay, so memory management is a very crucial things of table management. Without memory, it is going to be extremely difficult to do any kind of, though some of the things use some of the like direct relay and things like that, they use some of the things like analog computing and things like that. Okay, but computers usually do have a huge set of memory to do all the process management and other kinds of management or IO management table. So it is already linked to what is called the memory table. Okay, So some of the circuits, they don't need any kind of memory. They just switch to different things and go off. Okay, go on and off and things like that. So the basic early things that were developed as far logical circuits is concerned is a 0 or a 1. Okay, so when you give a 1, the other side is 1. That is, if you switch on the light, then the other side is going to be 1. So if you give a 1, the other side is 1. If you give a 0, the other side is 0. Okay, that is the basic logic circuit of a single line system. Okay, now the same thing, the second thing that was developed is NOT circuit. NOT circuit is a kind of, if you give a 0 on one side, then there will be a 1 on other side, and if you give a 1 on this side, then there will be a 0 on the side. So it's just an inverter. Okay, so the basic thing was, first is straight line through, and second one is inverter. Okay, so the first thing was called as a kind of buffer. Okay, buffer in the sense, it's a kind of there is a small time gap between the kind of thing which is input coming in and input going out. Okay, so when you want to read the circuit on the other side, you get a 1 there. So 1 means 1 on the other side, 0 means 0 on the other side. So this is the switching period. You have to take a small gap, time gap between the buffer. So basically buffer is what you should know. The first thing is a buffer construction, that is 0 means 0, 1 means 1. That is basically called a buffer circuit. Then 0 means 1, 1 means 0, means a NOT circuit. Okay, this is the alternating kind of thing. So when you switch on or switch off, so the current is on one side, and if you switch on the thing, then you have the current on the other side. So the switch is basically a buffer kind of situation. Then you have our 0 and a 1, and 1 and a 0 is a kind of inverter switch. Okay, inverter switch which gives you the different kind of, so the basically gate is formed. Okay, then the second circuit that was developed, so buffer, then NOT circuit, then after that you have an AND circuit. So you have two inputs and the 0 0 and you get a 0 on the other side, then you have a 0 0 0 1 on the other side, then you have a 0, then you have a 1 1 on the other side, then you have a 1. So when both circuits are odd, then you have a 1 on the side. So AND is usually used when you have two inputs. Okay, so single input system will be what, buffer and NOT. Okay, double input system will be, there is a combination. So you have AND circuit, OR circuit, NOT circuit, and OR, inclusive OR, exclusive OR, those kind of things are there. So NOT and those things are all different kinds of circuits that come into play. Okay, so the logic group, how about the complete system of logic groups? So 3 input is the maximum that you can have. Okay, so 2 input is the 1, and then they had 3 input kind of thing, which is an extension of 2. Okay, extension of 2. Okay, so 3 inputs you don't have to consider right at the beginning of the thing. So 2 input, what is the output you get and what is the drain you get. Okay, those kind of things. So carry, adder, carry, and those kind of things are all another one. So you have an adder, then you have a carry, then you have an adder circuit. There also are higher levels of AND circuit and OR circuit, or NOT circuit and buffer circuit. Okay, those are all higher orders. Computation is basically high order circuits of logical processing. Okay, that is the basic thing you have to understand. So high order circuits will be always a computer based on the high order, the low order logics of the circuit. So the low order logic circuits are what, and or exclusive or not an and these kinds are all low order circuits. And high order circuits are, you have a carry, that is 2 outputs will be there, 2 outputs depending on whether you want to add a number, subtract a number, or you have to have a logical rollover or a switchover. Those kind of things are the computational aspect comes with the second level of layering of gate management. Okay, so basic gates are, you already know, and buffer or circuit, buffer, not, and or, these are all the, so that is how the layering comes in. Okay, So single line, dual line, one output, then dual line, dual output, dual line, dual output will be a high order circuit. That is what. So basic things were they were all developed using what is called diodes. Diodes are the things which gives you, if you send a circuit on current on one side, there won't be a current on the other side. So diode is a kind of things which will do all the basic kind of thing. Okay, then they came in triodes were the best, which were using for normal calculations, like computer calculations, that is adding numbers, subtracting. Triode was used only as a kind of high order circuit. Okay, triode, pentode, and those kind of things of triode and quadrode was the pentode, and other things were used for calculations. Okay, so calculations of numbers were coming in only at the higher order levels of logical circuits. Okay, so that is the basic things of how the layering happens. So you have to understand the layering of how the processing happens. Those kind of things are there. Now we are going to do what is called a FPGA. What is a field programmer gate array? Okay, last time we saw what is a processor. Processor is basically a set of uh, processing which will execute the next instruction that is given on a particular process. Okay, so the process table will have all the next kind of instructions, and each instruction will be carried out based on what is given, what kind of instruction is given to the processor. So the basic instruction set and other things will be all details about those things are all, because we can go look up the hardware and other things out there. The early humans, when they started, the first thing was you have a socket like kind of thing. Then after that, you put in some grinding things, and then you put a huge stone over it, and then start grinding the thing. Okay, that is how the wheel was kind of thing. Okay, wheel kind of system of thing, where they started using the early nomads. They started using those kind of things for processing some of the kind of for food and other things. Okay, they used to cook, and then put the thing inside the socket kind of thing, and then they put a huge stone over it and started rolling the thing, and they grinded the whole thing and started eating those kind of things. Okay, so cooking and those kind of things are all done by what is called a socket kind of stones, and over the socket kind of stone they put a huge stone and grinding kind of stone, and then they started using some kind of grinders and other things. So the process means basically it starts from there. Something you are putting inside and something is coming out, and you're just churning the whole thing and then trying to get things out. Okay, so if you want big things, you want to make it smaller, or you want to make it like a paste or something like that, then it's a grinding kind of instrument that was used by early nomads as the wheel construction was concerned. Later it was completely they started inventing what is called a wheel. Okay, then after that they started inventing what is called automobile. Then after that they have the train structure, train, then the steam engine, then the electrical engines, and those kind of things were all developed. Okay, so those kind of things were developed. Here we are looking into why FPGA architecture is because we are going to do some kind of specific process kind of things can be done using FPGA. Okay, a basic FPGA architecture consists of thousands of fundamental elements called configurable logic blocks, CLBs, surrounded by a system of programmable interconnects called a fabric that routes signals between CLBs, input-output blocks, interface between the FPGA and external devices. Okay, it's called a fabric. Okay, it is called a fabric kind of things that route signals. So basically they are going to do some kind of routing is a control block kind of things which is going to do routing signals. Signals are basically some kind of input output kind of interfaces, blocks interfaces between FPGA and external devices. So they block the circuit in different kinds of things, forms and modes, and finally the output is, so it depends on what is the kind of system that input signals come in, what kind of output signals that go out. That is why it's called an FPGA architecture. Why FPGA was entered? A processor itself is enough for you to do, and you have a memory and they have to do all the things. But FPGA was an additional group which was doing some kind of fast processing of the signals. So every time you want to do some kind of signal processing and other things, they used FPGA for doing all the things like fast Fourier transform. Then you have other kinds of graphical kind of things which they required kind of fast processing and getting the signals out on the proper channel and those kind of things. So a basic FPGA architecture, field programmable gate array, consists of thousands of fundamental elements called configurable logic blocks, okay, surrounded by a system of programmable interconnects. So you can use a program, you can use construct different kinds of programs on this called a fabric. So over the fabric you give different kinds of programs, any kind of what kind of input signals would be there, what kind of output signals will be coming out. That is why it is called programmable. Programmable means you can change at any time and then make the things work, okay, but you cannot use it always. The whole thing can be used as a processor, but it defeats the purpose of the processor also. So that is why field programmable things are not mostly used for kind of processing some of the signals only, okay. They are not used for any kind of higher levels of things and kind of things, and some of the things are used for some kind of memory kind of unit and other things, okay. What is FPGA used for? First and foremost, FPGA are used to design application-specific integrated circuits, ASICs. They are called ASICs. For a particular kind of application, you need what is called an integrated circuits. Okay, what is integrated circuits? Circuits which are integrated. So you have one set of circuits, then they have another set of circuits. These inputs go, the outputs of one is connected to the input of the other. These kinds of connection between those kind of different kinds of circuits is called what is called an integrated circuits. Integrated means taking the input of one and giving the taking the output of one and then giving as an input to the other one, and taking the output of the other one and giving it to the, so this thing cascading kind of architecture was what are called ASICs, okay, application specific integrated circuits. So for a specific applications you have to do some kind of for signal management, flow management. That is why they have application specific integrated circuits. First you design the architecture such a circuit, then you use a FPGA to build and check its prototype, okay. So first you have to design the architecture of such a circuit. So first you have to design the architecture of such a circuit, then you use a FPGA to build, okay, field programmable gate array. So first thing you have to design the thing, okay. For a particular circuit you have to design the thing, and then you just field program the whole thing inside the FPGA, and you get the output based on what is given. So that is why for a specific applications, okay. Some of the applications they needed on the run, okay. So the repeated kind of applications and other things were usually done by ASICs and field programmable FPGA. What is a FPGA design? Okay, field programmable gate arrays and semiconductors that are based around a matrix of configurable logic blocks. Okay, so if you have a huge matrix kind of system, okay, huge matrix kind of systems with different logical blocks, okay, then you want to get the whole thing programmable and interconnects, and then finally you want the output coming in or signal processing and other things. They use what is called a FPGA, okay. So field programmable based on matrix. Matrix is a huge thing. Matrix is supposed to be in a kind of set of inputs and converting all the inputs into different forms and giving weights and other things, those kind of. So artificial intelligence, they use this, some of the artificial intelligence AI chips, they use what is called a field programmable gate array logics, okay. They basically use it for some of the weather processing, and the FPGA is mostly used for weather processing, some kind of control management groups and things like, for mostly for some kind of your air conditioning control, and those kind of things are all done immediately, and you want the signals out to be, those kind of things are all used by FPGA programming kind of things. Processor architecture usually is a kind of a little bit different, okay. You can use a field programmable thing to do processor architecture, but the kind of writing that they use for higher level language that they use for kind of C++ kind of things, and FPGA design specific, that's Xilinx Bidado HLC compiler provides a programming environment that shared by technology, both standard and specific. What is FPGA? Program is used in FPGA. What is the program used to? So you have to write a program to do the programming, okay. So first you have to write a program and it will be compiled. That program will be compiled, and after that, once the program is compiled, it is put on to the chip as a kind of fixed kind of thing. Okay, some of the things are variable kind of things which we'll look into later. Okay, there are two different types of kind of field programmable array logic. So for first one is kind of like fixed kind of thing, then it's a loose kind of architecture. So two types of architectures are there. So mostly they are developed as a higher level language. Then the whole circuitry, everything is developed with using a higher level language. From the higher level language, it is converted to lower kind of logical gate arrays like AND circuit or circuit, and then the complete thing is programmed. Okay, programmed down to the chip so that you finally have the outputs for the specific kind of application that you are doing. Okay, is FPGA microcontroller, a field programmable gate or grid array, and a microcontroller similar but not the same. They are actually similar things, okay, but not the same. Why they are not the same? Because the amount of matrix that goes in a field program is quite huge. Okay, and if you are doing a small thing, then it is called a microcontroller. Only a small part of the FPGA is called a microcontroller, similar but not the same. They are both essentially small computers or integrated circuits. Both essentially are small computers, but they also doing some kind of calculation work. Not calculation work, actually they are converting the signals into different types of signals and then giving the output for a specific applications, those kind of things. For a chess game or something like that, FPGAs are used. For processing the your screen and other things, the FPGA use. For processing, quick processing of the say you're typing and something, the IO has to be converted into some kind of bit forms and other things. Those kind of things are all done by FPGA. Okay, so even in kind of artificial vision control, those kind of things are all done by FPGA is the first one which used in vision. Okay, vision or pattern recognition and those kind of things. Okay, they are used there also in artificial. Is FPGA faster than CPU? FPGA can hit the data cells faster and more often than a CPU can do, so they can get the data cells very fast, meaning that FPGA costs more results to occur during an attack. It also gives faster than FPGA is used. So it is more like kind of not a kind of memory where it is stored and forwarded kind of thing. It is more like a CPU, but only thing it gives access to the CPU extremely fast signal processing. Okay, so that is why it is called a FPGA can hit the data cell faster and more often than a CPU can. So CPU is going to be a little bit slower on getting the cells faster and doing the processing faster. They can do the processing because you have to get into the memory. From the memory you have to load it onto the kind of CPU, and then from the CPU it has to be processed, and then finally the results are written at the table. But FPGA is a direct kind of thing where the signal is taken in directly and signal is given out directly. So for application specific use of that particular thing is used by only by FPGA data. So they are also faster. Okay, it's faster signal processing kind of unit which is attached to the CPU to do some of the core normal cores of kind of environment. Okay, where you want to develop some other things for application, for a specific application and other things. Is FPGA faster than GPU? Compared with GPU, FPGA can deliver superior performance deep learning applications where low latency is critical. Okay, so latency is one of the critical things of learning systems. Okay, so latency is the time. Latency means time. If we want to immediately take action for a particular kind of, say your eye is there, so you are seeing something and immediately some car is moving, so immediately you have to take a immediate decision to move out of the place within fraction of nanoseconds and things like that. So those kind of things are critical things, are all done by FPGA. It is a kind of motor nerve and sensory nerves. Okay, sensory nerves and motor nerves are all immediate response kind of center, those kind of things. And deep learning is so performance deep learning. FPGA can deliver superior performance deep learning applications where low latency is great. So deep learning performance can be improved by kind of FPGA. So machine learning is a lower level where it can be field programmable thing is done, and deep learning is faster because of FPGA, because the learning process goes on the memory kind of structures where it is to learn all the things. Okay, so the deep learning and machine learning. So machine learning is integrated, FPGA is integrated to FPGAs, and because of that the deep learning process is very fast. Okay, that is why you have so FPGA faster than GPU and things like that. what is uh, Arduino and FPGA. What is Arduino? Arduino is a microprocess, microcontroller, and an FPGA is a completely different beast. Okay, so Arduino is very similar to a normal PC CPU. So there is this basic CPU kind of things, a smaller size version of a CPU. So like 8081 or those kind of smaller versions of this, they are called Arduino. Okay, those kind of things. So microcontrollers. They are Arduino is a microprocessor, microcontroller. It's a microprocessor and it's a microcontroller. But when you do an FPGA, it is a completely different kinds of thing where the signal is done, processing is done for a different kind of environment very fast. Okay, language that gets compiled to machine code that the processor executes sequentially. You write code in a high level language that gets compiled to machine code that the processor executes sequentially. So you have to do step by step sequence of processing is done in CPU kind of environment and microcontroller environment, but sequential processing is not done in FPGA is directly controlled. Okay, so immediately you get the signals out on the other side. That is why it is much faster. Okay, so the for specific applications and other things, so use Python language. What is the kind of thing? The National Instrument FPGA interface Python API is used for communication between processor and FPGA within NI configuration. So how do you communicate between the processor and the FPGA? The National Instruments FPGA interface Python API. So Python API is the one which is used for communication between processor and FPGA with NI configuration. So these are the critical things that you have to know. IO hardware and NI compact RIO, NI signal board RIO, and NI flex RIO, and those kind of things. Okay, remote IO, and then go ahead. APS document is a PLC and FPGA. Okay, there's another called the thing called PLC. So programmable logic controller. Okay, that is the two things are completely different. FP gas and build blocks of electronic systems. Okay, PLCs are systems. Okay, PLCs are systems. Okay, you have a complete system running on the whole thing. So PLCs are different from FPGA. Okay, so FPGA are direct kind of processing. PLCs are a kind of systems itself. It is a whole thing. The two things are completely different. FP gas are built or building blocks of electronic systems. So FPGAs are building blocks of electronic system. PLCs are systems itself. Okay, there's a difference. They are called programmable logic controllers. Okay, what are limitations of FPGA? Okay, slower size of data set, complexity more expensive than custom silicon, no analog stuff. Okay, cannot get as much circuitry on a single chip. So you cannot get much of the circuitry on the single chip to do much of processing, but they are kind of a bit faster and they get the data set done. But complexity is quite high for FPGAs. Because of that, they have a disadvantage of the whole thing. Is FPGA in embedded system? Is FPGA in embedded system? In fact, microcontroller, FPGA, and CPLD, complex programmable logic devices, are independent embedded systems. They are all different kinds of independent embedded systems. What are embedded systems? There are different kinds of controllers, FPGAs, CPLD, and those different devices embedded into a whole circuit board. Okay, including microprocessor and other things. Okay, so when you look at a huge motherboard, you'll see so many different things. Why are those so many different components coming in? Already you have to see only three components. One is a processor component, then it's a memory component, and then a small IO component. That's all. But you'll see so many other things coming into the thing. Why they have so many kinds of other things components? These are all microcontrollers, FPGAs, and CPLDs, complex programmable logic arrays, and independent embedded system. They are called what are called embedded systems to do some of the processing for you as a kind of slave kind of a master slave kind of environment. Multi-threading and all those things are used for such kind of environment. That is why you see a board or a PCB with so many kind of devices on it. Okay, otherwise it's a single thing which is just has only three components. One is a processor component, memory component, and other one is other one is IO component, which is you have an IO port. That's all. Okay, so these are the three things of a main motherboard. But there are other things inside which are small chips coming in. They do different kinds of processing and support kind of environment and doing fast multi-threading and multiprocessing, and those kind of things are all done by microcontrollers, FPGA and CPLD, complex programmable logic devices, are independent embedded system. They are called embedded system. They are called systems which are embedded into other kinds of systems is called an embedded system. Field programmable gate arrays. Can FPGA replace CPU? There will always need for general purpose CPU to run most things, while you can implement a CPU on a FPGA that gives you the worst of both worlds, no improvement. So you don't have any kind of improvements on the thing. So there is no need to use FPGA. They cannot replace CPUs and other things. Those kind of things are should be there. What is FPGA made of? FPGA is made of thousands of configurable logic blocks. The logic blocks is a kind of like, say we want to add a 10-digit number to a 10-digit number, then every logic can do it immediately and get the output out. These are called the configurable embedded in the case of programmer interconnects. So FPGA is thousands of the counters. So if you want to do a matrix multiplication, so you cannot use the CPU for that. So immediately give it to the FPGA to do the matrix multiplication and give you the output immediately. So that one particular CLB is embedded is an ocean of program interconnect configurable logic blocks. So they are just configured to do a matrix multiplication, that is kind of FPGA which does all the things. Why they do matrix multiplication is because of, if you have a screen or you have a kind of a keyboard and other things, though they take the input faster and do the processing immediately. Instead of processing, the signal is directly processed and given out, so that the memory units and CPUs can use them. Okay, that's all. What are the advantages of FPGA? Okay, long-term availability, updating and adaptation of the customer. So if the customer wants specific kind of things, then the long-term availability, they have long-term availability. So you don't have to, every time, kind of once it's programmed, then you can use it for quite a long time for a specific kind of adaptation for a particular kind of circuitry. Very short time to markets. They have very short time to market. Okay, fast and efficient systems, acceleration of software, real-time applications, massively parallel data processing. So mostly massively parallel data processing is done because of FPGA. FPGA help in those kind of environment. So FPGA usually used for multiprocessing, accelerated software, real-time applications. When they have real-time applications, accelerated software, fast and efficient, you want signal processing extremely done very fast, or kind of vision processing, or kind of pattern recognition. Those kind of things are all using FPGAs. Okay, updating and adaptation of the customer. So for a specific customer, you want to have some kind of signal very fast, then they do it on FPGA for a specific set of input output. Okay, CPA FPGA, CPA FPGA. FPGA program gate arrays are types of integrated circuits, programmable hardware fabric. This differs from the graphical processing GPUs and CPUs. Okay, in that the function circuitry inside a FPGA process is not hard edged. Okay, in the sense that it is not because it is programmable, it is not immediately hard edged. So the field programmable gate arrays are types of integrated circuit with programmable hardware fabric. So you can usually program those kind of circuits, whereas the CPU and other things, you cannot immediately program the whole thing. There is a program which will run on that, but there won't be any kind of, you cannot program those kind of CPUs. Okay, that is the difference between the kind of processor, CPUs and other things. Okay, so basically for graphics, and the GPUs can use FPGA architecture and other things. GPUs means graphical processing units. Okay, so if you want to do any kind of graphical processing, IO processing, other things, then you can use it for FPGA. Do FPGA have processor? Okay, there is no processor. Processors FPGA can be hard or soft. Hard processor implemented fixed silicon. So there can be two types of FPGAs. One can be hard processor, soft processor in associate. Okay, hard processor implemented in the fixed silicon logic of the FPGA, similar to the serial transceivers on SoC. However, the process is surrounded by programmable logic that you can use it for custom or application specific functions. So there are two kinds of FPGA use. One is hard program, another one is software. The soft program is where you can change the whole thing to whichever kind of implementation that you want. The hard one is a kind of gate array kind of thing, which is already kind of programmed and do specific functions of the whole thing. Okay, so this is the do FPGAs have processor? So they have a small limiter kind of how fast can FPGA run. Okay, so that is one thing. A clock in an FPGA system is responsible for driving the FPGA and determines how fast it can run and process data, with the numbers reaching a maximum of up to about 1 gigahertz. So they can, when you have other things, they can usually go up to high speed. That is why the FPGAs are used by about 1 gigahertz and other things. Signal processing at that level of 1 gigahertz is quite difficult. That is why they are using FPGA, and that is why they are programmed immediately and then the output is given. So because the memory architecture is a little bit slow, so that is why they use FPGA and GPUs and other things. Okay, so this is general introductory level of FPGA. Now how to program these things? FPGA is programmed. So that is the higher level language which will be used, and the different types of programming languages. The one is called behavioral programming, one is called functional programming, then have systemic programming and things like that. So there are three different kinds of architecture for kind of FPGAs to program an FPGA. So usually in VLSI design, okay, very large scale integrated circuits are used. VLSI designs, they use the three different basic things which they use for hardware programming. Okay, there's separate programming structures for hardware programming, and we look into what are the different kind of very high BSDL and those kind of things are all there. There is another kind of set of languages which you use for other kinds of BSDL and other things. Okay, so this is just an introductory on pre-programmable gate arrays and how it is used in AI, and how you use in application specific faster processing, how it is used in graphical user to faster processing, how we can use it for even memory units. Some of the things can be used even for memory as a kind of flash kind of environment. Those kind of things are all there as the basics of FPGA and what is the use. That is what we wanted to see today, and how we integrate it to your processor, how you build up other kinds of systems and other things, why they are used. Those kind of things are all done today. Okay, that is all for today. Last time we saw the BSC system. This time what is a table management group and things like that. So similar things will be looked into later. Okay, so FPGA is a basically a very advanced field that is coming into play right now, because some of the things are time critical and those kind of things are there. That is why they are using all the FPGAs nowadays. Most of the boards have FPGA for doing in a multiprocessor environment and other things. So FPGAs are very critical, those kind of things. One is hard, the another is soft. So both of things, they require some kind of field programming. So you have to program the particular thing into a specific function or a specific application to do a particular kind of work which needs faster signal processing comparable to that of the processor. Okay, processor or multi-threading kind of environment. Okay, that is all for today.